Recently, a discovery has captivated the attention of scientists and space enthusiasts alike. Bill Nye, a well-known science communicator, made headlines when he announced that Voyager 1 had detected 300 massive objects in space. This revelation has not only ignited curiosity, but also raised profound questions. What exactly are these objects, and where do they come from? Join us as we explore the mysteries hinted at by Voyager 1's astonishing findings. For nearly 5 decades, the Voyager missions have provided some of the earliest and most extraordinary views of our solar system's wonders. Surprisingly, these missions were never designed to last this long. Back in the 1970s, mathematician and engineer Michael Minovich proposed a revolutionary idea. A spacecraft could use a planet's gravity and motion to slingshot itself deeper into space. Originally intended to last only 5 years, the Voyager mission far exceeded expectations. Launched weeks apart in the summer of 1977, Voyager 1 and Voyager 2 were first tasked with exploring Jupiter and Saturn. They returned breathtaking close-up images and data from these giant worlds. But the mission didn't stop there. Voyager 2 went on to become the first spacecraft to closely study Uranus in 1986 and Neptune in 1989. These historic flybys became known as the Grand Tour. Instead of retiring, both spacecraft continued onward toward deep space. In 2013, NASA announced that Voyager 1 had officially entered interstellar space, the region beyond the Sun's dominant particle influence. It was humanity's first direct step into the space between stars. Voyager 2 followed in 2018. Even today, these spacecraft remain the only human-made objects to enter interstellar space. There, they study how the interstellar medium interacts with the solar wind. Their discoveries transformed our understanding of the heliosphere, the giant protective bubble created by the Sun's charged particles. This bubble shields the solar system from much of the harsh radiation of deep space. At its outer edge lies the heliopause, the boundary where the solar wind meets interstellar space. Voyager revealed that cosmic rays beyond this boundary are around 3 times more intense than inside the heliosphere. It is like stepping from a calm backyard into a crowded, chaotic city street. Then came another surprise. In 2023, Voyager 1 detected a faint, low humming signal. Scientists believe it matched vibrations caused by thin gas drifting through interstellar space. It was the sound of the emptiness between stars. Nicola Fox emphasized how valuable the mission has been, explaining that Voyager has transformed our understanding of the Sun in ways no other spacecraft could. What makes this more remarkable is Voyager's age. Both probes are powered by plutonium systems that slowly lose strength each year. To conserve energy, NASA has shut down heaters and non-essential systems. Yet many core instruments still function. Scientists remain amazed that the spacecraft continue operating in temperatures where most electronics would fail. It is one more mystery added to Voyager's legend. The heliopause itself may not be stable. Data from Voyager and IBEX suggests this boundary shifts, bends, and changes shape over time. Researchers noticed unusual particle brightenings and sudden movements of the boundary. These changes may explain why Voyager 1 crossed into interstellar space years before Voyager 2, even though both followed similar outward paths. In studies published by Nature Astronomy, scientists described these findings as surprising and important enough to challenge older models of the solar system's edge. To solve these mysteries, NASA prepared the IMAP mission, designed to study the boundaries of our solar neighborhood in far greater detail. Yet even while science advances, Voyager itself keeps surprising. In May 2023, Voyager 1 experienced a strange communications anomaly. Its attitude articulation and control system, the system responsible for keeping the high-gain antenna pointed toward Earth, began sending confusing and seemingly random data. From Earth, it looked as if the spacecraft had become disoriented. Yet strangely, its radio signal remained strong and stable. The antenna was still accurately pointed toward our planet. Even more surprising, Voyager's scientific instruments continued working normally, and its fault protection system never activated. NASA later discovered that the system was routing data through an inactive onboard computer. Engineers sent commands to switch transmissions back to the correct system, solving the issue. Still, the real cause remains uncertain. Some experts suspect cosmic radiation may have flipped memory bits in the aging computer. That possibility is not far-fetched. Voyager now travels beyond the Sun's magnetic shield, where energetic particles constantly bombard its electronics. These particles can cause tiny errors in memory and software. Suzanne Dodd explained that such anomalies are expected for spacecraft operating in an environment no machine was ever designed to endure for so long. Remember, these probes were launched in the 1970s. Their computers have only around 70 kilobytes of memory, less than many digital watches. Yet engineers still maintain and update them across billions of kilometers. Keeping Voyager alive is like providing IT support to a machine drifting between the stars. Despite primitive hardware, Voyager changed planetary science forever. At Jupiter, it discovered violent storms, brilliant auroras, and faint rains. At Saturn, it revealed thousands of delicate ring structures far more complex than expected. On Jupiter's moon Io, Voyager found active volcanoes erupting in space. On Triton, it observed nitrogen geysers blasting upward in extreme cold. Perhaps most exciting were hints of possible life. Voyager data helped reveal that Europa and Enceladus likely hide vast salty oceans beneath icy crusts. These worlds are now considered prime targets in the search for extraterrestrial life. One of Voyager's most emotional moments came when it turned back for a final photograph of Earth. At the suggestion of Carl Sagan, it captured the iconic image known as the pale blue dot. That tiny speck of light, suspended in a sunbeam, reminded humanity how small and fragile our world truly is. Today, Voyager 1 is so distant that a radio signal takes more than 22 hours to reach Earth. Voyager 2 takes nearly 19 hours. Every day they move farther away into the dark. Communication is maintained through NASA's Deep Space Network, giant antennas spread around Earth that listen for the faintest whispers from space. The mission itself happened because of a rare planetary alignment discovered by Gary Flandreau. This once-in-a-lifetime arrangement allowed a spacecraft to visit multiple outer planets using gravity assists. NASA seized the opportunity, and the result became one of the greatest exploration missions in history. Nearly 50 years later, Voyager 1 and Voyager 2 remain humanity's farthest emissaries. They continue carrying our curiosity into the unknown, crossing boundaries no other spacecraft has reached. Their signals may be faint,